Welcome everyone to this video. Uh, so we want to discuss in this one the chapter of waves. So basically, waves is a chapter which uh, entails a lot of concepts. So let us look at this slide. What are the important characteristics of a wave? So for a transverse mechanical wave, basically, the vibrating particles are at different distances. So this means that is a particle somewhere here, P1. It is at a distance some y1 from the mean position of the vibration, and there is some other particle P2 which is at some y2 displacement from the mean position of the particle. So from this figure, we learn the concept of mean position. So mean position is the point about which the particles vibrate in transverse direction. And by transverse, I mean vertical direction. So they vibrate in such a way that it almost seems that the wave is traveling in forward direction. But what is actually happening is that particles are vibrating in some small phase difference with respect to each other. So this helps us in achieving some kind of motion which is not almost, which is absolutely smooth kind of uh, in its uh, perception. But it's actually each particle following its own path. So if I were to traverse the path of each particle, the particle vibration would be something like this. But as such, we have the wave is traveling in some forward direction. The maximum particle displacement is called crest. So these are some crests. And negative y displacement are called troughs. The distance between two consecutive crests is called the wavelength of the wave, or two consecutive points which are in the same phase. So that means that if I have a wave equation looking like this, y is equal to a sine kx minus omega t. So I will say that this quantity is called the phase of the motion. So what is the minimum change in x for which the displacement of the particle is the same as what we are seeing at this position and time. So that minimum change in x is called the wavelength of the wave. So we say that okay, let us change x by some delta x distance. Right, you can take it as negative x as well. There is no basically boundation to that. We'll get the same answer. So if we subtract this current phase, that is kx plus delta x minus omega t, with the earlier phase kx minus omega t, and we say that the phase difference between two points is 2 pi. So we say that delta x, that is wavelength of the wave, is equal to 2 pi by k. So this is what we mean by wavelength of the wave. It is basically that distance between 2 points, two consecutive points, which are in the same phase. Wave pulse. So we want to do one question before ending this video. Yes, let us do this. So this is traveling sine wave in one dimension. So here question can something look like, okay, if I have an equation y is equal to a sine omega t minus x by v, what is the value of k? So first of all, this is traveling sine wave in one dimension as it is written here. What do you mean by k? It is a traveling wave. Traveling wave means that k, the energy of the wave is passing from one point to another, or the momentum of the wave is passing on. So that's why we say it's a traveling wave. Uh, and it's a sine wave because it's a trigonometric function. Then question can be, what is the angular wave number of the wave? So the angular wave number is the coefficient of x. So omega by v, this is the coefficient here, which is k. So thank you for joining. We have a little bit of more time, yes. So this is what is k. This is called angular wave number. So what we say is that k v is equal to omega upon k, and 2 pi by t is equal to lambda by 2 pi. So lambda by t is equal to wave velocity. Omega t minus omega by v into x. So these are the some derivations which we can do. So from this we learned that omega is equal to 2 pi by t and k is equal to 2 pi by lambda.